condition for tangency to a parabola. Now what this basically means is that we are given a line and a conic. What we have to figure out is when will the line be a tangent to the conic if it is given to us in a standard form. Okay. Now there are different ways in which the line may be given to us. So let's say the line is given to us in y is equal to mx plus c in this form. Let's say we are given a parabola, that is y square is equal to 4ax. Now the parabola looks like this, right? If it is in standard form. So if you observe a horizontal line, that is a line parallel to the axis of the parabola, will always cut this parabola only once. So y is equal to c cuts the parabola at only one point, but they are not tangent. So let y is equal to mx plus c be a line not parallel to the axis of the parabola. So which implies that m is not equal to 0. Okay, so this is something that we can figure out from the diagram itself. So let's say the given parabola is y square is equal to 4ax and we are given the line y is equal to mx plus c. So let's solve both. Now how do we solve both? We substitute the second one in the first one. Mx plus c square is equal to 4ax. Now this would be m square x square plus 2mxc plus c square is equal to 4ax. Now let's bring in 4ax to this side. So this becomes minus 4ax equal to 0. Now here this is x square, there is x here. So let's rearrange it. Plus 2 is common to this and this. mc minus 2a x plus c square equal to 0. So here you have x square, here you have x, and here you have no x. So which means it's a quadratic equation. Now the line would be a tangent if it meets the parabola at only one point. Okay, so which basically means the roots of this quadratic equation are equal. Okay, and the roots will be equal if b square minus 4ac is equal to 0. Okay, so here what is b square, what is b, what is a, what is c? b is mc minus 2a, a is m square, and c is c square. So a is m square, b is 2 times mc minus 2a, and c is c square. So now let's substitute it here. 2 times mc minus 2a square minus 4 times m square times c square is equal to 0. 4 m square c square minus 4mca plus 4a square minus 4m square c square equal to 0. 4, take 4 common here and here. So m square c square minus 4mca plus 4a square minus m square c square equal to 0. Now 4 goes to the other side, gets cancelled or becomes 0. M square c square gets cancelled, and we are left with minus 4mca is equal to minus 4a square. 4 gets cancelled, one of the a's gets cancelled, minus gets cancelled. So mc is equal to a, or we can say c is equal to a by m. So this is the condition. If c is equal to a by m of the line equal to mx plus c, then in that case the line is a tangent to the parabola. And there is another way in which this can be looked at. Let y is equal to mx plus c be a tangent to y square equal to 4ax. Now, in previous sessions we have seen that equation of tangent to the parabola at x1 y1 is y1 is equal to 2ax plus x1. So we are saying that this is the tangent and this is the tangent at x1 y1. So that means they both represent the same line. So which implies that the corresponding coefficients are proportional, which means, so let's write down y is equal to mx plus c, y1 is equal to 2ax plus x1, or what we can do is let's expand it off, 2ax plus 2ax1. Now x1 is, remember, x1 y1 are the given at a point, right? So that point doesn't change. The only thing that will change is x and y. So let's look at the proportionality. So let's look at the proportionality. Coefficient of y is y1 by coefficient of y in the first one is 1 is equal to 2a by m is equal to 2ax1 by c. So now what we'll do is we want x1 and y1. So we will look at this and we will look at this. So let's take the first one, y1 by 1 is equal to 2a by m. This implies that y1 is equal to 2a by m. Okay, now let's look at the other one. 2a by m is equal to 2ax1 by c. So a gets cancelled, a and 2 gets cancelled, and we are left with x1 is equal to c by m. So therefore coordinates of the point of contact of the tangent to the parabola is, we assume that it is x1, we assume that it is x1 y1, so which is equal to c by m, 2a by m. Now since x1 is the y1 is the point of contact. So x1 y1 lies on the line y is equal to mx plus c. So which means we can say y1 is equal to mx1 plus c. So let's do the substitution of x1 y1. So y1 is 2a by m is equal to m times x1 is c by m plus c. So this m gets cancelled. 2a by m is equal to 2c. 2 gets cancelled. So c is equal to a by m. And if you look at this, c is equal to a by m. So through both the methods we got the same result. Now 2 points. Y is equal to mx plus is always a tangent to a parabola, to the parabola. We took that line y is equal to mx plus c and we substituted in place of c a by m. Okay, so if you look at this equation very clearly, only one tangent can be drawn parallel to a given line. Okay, so that is tangency of a line, or rather the condition for tangency of a line. That's it. Bye for now.